Hello, today we are going to be evaluating the limit of this exponential equation as x approaches 0. So we know that the limit of e to the x as x approaches 0 is going to be 1. Likewise, the limit of e to the 2x is also 1 as x nears 0. So we might be tempted to go have a look at our equation here and just kind of swap out the terms e to the 2x and e to the x with 1. But if we have a quick look at our denominator right here, we have e to the 2x minus 1. So when x nears 0, we actually get a denominator that nears 1 minus 1 or 0. Meaning in this instance we have an undetermined form. So we're going to need to work another way around this blockade. We can also see that we have the terms e to the 2x and e to the 2x above and below for our equation. So we might be tempted to factorize by this term of highest degree. But following that train of thought, we would actually fall into the same exact issue with a denominator that goes towards 0 as x approaches 0. So we're going to need to find another way of solving this. We can see that we have plenty of e's and x's kind of all over this equation, and it's all very clustered and difficult to visualize. So we're going to let y be equal to our e to the x. And this y is going to have the same exact limit as e to the x when x approaches 0, and that is going to be 1. So we're going to rewrite our equation now. We have the limit of e to the 2x, but that's going to be the same thing as the limit of e to the x squared. And we already have established that our e to the x is just going to be represented as a y, so we're going to have y squared. Then we're going to have plus 4e to the x, or plus 4y, minus 5, the whole thing over again, y squared minus 1. And here we have x approaching 0. But it's a bit odd to write here that we have x approaching 0 when we don't even really have an x in this equation that we've just written. So we're going to rewrite that as y approaching 1. So now we've got a second degree polynomial for the numerator and the denominator. So we might be tempted to try and factorize this and see where it goes. For our numerator, we can clearly see that 1 is one of our roots. So we can use the following formula to try and find our second root. So we have 1 times the second unknown root is equal to c over a. But in this case, our c is equal to minus 5. So we have minus 5, and a is equal to 1. So over 1, meaning our second root is actually just going to be equal to minus 5. Then, for our denominator, we have y squared minus 1. But this is actually the same thing as y squared minus 1 squared, which goes back to the identity of a minus b, factor of a plus b, with here a being equal to y and b equal to 1. So we can rewrite the denominator as y minus 1 factor of y plus 1. Meaning we can rewrite our entire equation as being the limit of y minus 1 factor of y plus 5, the whole thing over y minus 1 factor of y plus 1, again with y approaching 1. So this, in this instance, we can actually cancel out the terms y minus 1, which simplifies our expression to being y plus 5 over y plus 1. And here, y is approaching 1, hence we actually have y plus 5 over 1 plus 1, which means gonna draw a goofy arrow here. We actually have a limit that is going to approach 6 over 2 or 3. And that's our answer. As x nears 0, this equation is going to approach 3. Thank you for listening. I hope you enjoyed the video.